Hi students, good morning all. This is Anita from CSE department. In this semester, I'm gonna teach you computer organization. So this computer organization is one of the core subject in your second year, fourth semester. And the course code of this computer organization is PC 232 CS. So in this computer organization, you will be going to study different things which are very majorly important. In this first class, as it is the first class, what we will be going to do is we will be going to discuss regarding the course outcomes, what are the course objectives, and finally the syllabi of the computer organization. Fine. And majorly this computer organization subject, like you will be going to have 3 credits for theory and 1 credit for lab. For this computer organization, you will be also going to have a lab practical session. Previously it has been introduced from your seniors onwards. For your super seniors, actually there will be no lab, and it is very beneficial for you if you go on doing the practical session along with the theory. So that is the benefit of having the lab. Fine. In this class we will be going to discuss regarding the syllabus and the course outcomes. Fine. So what are course outcomes? So course outcomes are nothing but, like, after studying the complete course, after studying this computer organization complete course, finally what you are getting, that we will be going to call it as a course outcomes. Finally, in the sense, at the output, you can say it is an output. So after studying the 5 units, what you are going to gain with, and to which extent your knowledge you have gained with, all the things you will be going to consider in the course outcomes. Fine. In this course outcomes, the first and the foremost course outcome is, like, after this, students understand in a better way the IO and memory organization in depth. So IO organization is nothing but input output organization. Fine. IO, you will be going to say it as an input output organization. Let me clear you first. What do you mean by an organization? Like, you will be going to have actually the subject is COA, computer organization and architecture. Fine. If you go for JNTU, you will be going to find the COA. Now you will be going to have a CO, only computer organization, and for IT students it is CO and MP, computer organization and microprocessor. Let us discuss like CO in the sense computer organization. So let me tell you difference between the computer organization and the computer architecture. So as you are well aware of it, architecture is nothing but the hardware components that are connected together, that we call it as an architecture. How the hardware components are connected, at which point they have been interfaced, all the hardware connections, we will be going to say it as an architecture. Fine. So simply this architecture we can say it as an hardware. Fine. Hardware components which are going to be connected, so this we call it as an architecture. So when it comes to the computer organization, so organization deals with the structure. Organization deals with the structure and behavior. So when we are going to talk regarding the organization, this organization is going to deal with the structure and behavior of the computer system. So this is the major difference between the computer architecture and computer organization. This is a very important when it comes in your Viva. So what is the major difference between computer architecture and computer organization? In the sense, computer architecture deals with the hardware components, whereas the computer organization deals with the structure and behavior of the system. or structure or behavior of the computer system. So that is the major difference between the architecture and the organization. So here in this subject what we are going to learn is organization. Organization in the sense we are going to deal or we are going to concern with the structure and behavior of the computer, but not with the hardware components or something else. So this is one of the major important difference between the computer architecture and the computer organization. And another important major difference is, so architecture deals with the functional behaviors, whereas the organization is going to deal with the structural behaviors. So this is also a very important point when it comes to the differences between the architecture and the organization. So in general we can say that architecture indicates the hardware, whereas organization indicates the performance, like means structure and behavior in the sense finally we can conclude that it is a performance. So that is the major difference between the architecture and the organization. So in this first outcome, like you will be going to understand in a better way that the IO and the memory organization. So how the inputs and outputs are going to be organized, how the inputs are outputs going to be structured, and what is the behavior of input output organization, and also the memory organization. And so like memory, when it comes to memory, which is going to play a very important role. So without memory there is nothing. So this memory organization is going to plays a vital role when it comes to this computer organization. So we are having different types of memories, right? As you all know, we are having RAM, ROM, cache memory, nowadays virtual memory and associative memory. So you will be going to come up with all different types of memory. So we will be going to study this input output organization as well as the memory organization in depth. And the next one is, which is ability to understand the merits and demerits in a computer performance measurements. So advantages, what are the advantages and what are the drawbacks in a computer performance measurements also you will be coming to know across. So when it comes from the third unit, you will be going to switch into 8086 microprocessor. So you will be going to study the 8086 microprocessor. So the first two units are going to concern with the hardware structure and behavior, and when it comes to the this third unit, you will be going to coming up with the microprocessor. So what do you mean by a microprocessor? So as you people are well aware of it, like it is an electronic component. So what is that electronic component consists of in the sense, we can say this microprocessor is nothing but a central processing unit. So in where this all the millions and trillions of transistors, resistors, diodes, they all work together in order to do a specific task. So all those transistors, resistors, capacitors, all are integrated on a circuit or a single chip. That chip we call it as a microprocessor. So here we will be going to study regarding the 8086 microprocessor. There are different kinds of types of microprocessors, 8257, 8085, 8086. There are many different types of microprocessors, but in your curriculum, in your third unit, like you will be going to study regarding this 8086 microprocessor. So when you are studying this 8086 microprocessor, the extension of this 8086 microprocessor you will be going to study in this fourth unit. Extension in the sense the instruction set of 8086 microprocessor, and also you will be going to write the assembly language programs. So when you are going to write a code for the microprocessor, you have to write that code in mnemonic language. So mnemonics means, so you have heard this high level language and low level language. This is another different type of language, which is the mnemonic language. So you will be coming across the examples and the small programs. You will be also writing that programs in this mnemonic language. You will be going to have the MOV, ADD. You will be going to have a different instruction set in order to do the programs for the microprocessor. So all those things you will be going to study in the fourth unit. And the last and the final unit is demonstrate fundamental understanding on the operation between the microprocessor and its interfacing devices. So what are the interfacing devices? So in order to have interaction between any two components, we need an interface. So by making use of that interface, like you will be going to connect any two components to work synchronously. So what are those interfacing devices, and what are which microprocessor we call it as an interfacing microprocessor? All the things you will be going to study in this 5 unit. So these are the different course outcomes you will be going to have. Like after completing of this course, after the completion of this course, you will be coming up with the input output organization, memory organization, and what are the merits and demerits of performance measurements, and mainly the 8086 microprocessor, and how to write an assembly language programs for the 8086 microprocessor, and finally how to do the interfacing. So all these are the things you will be going to learn in this computer organization. Fine. These are the course outcomes. And when it comes to the objectives, so when it comes to the objectives, like you will be going to understand the basic components of the computer, and you will be going to have the input output organization in depth, and to explore the memory organization. So to understand the basic chip design of 8086 microprocessor. So all these are the things you will be going to learn. I mean, these are the things that are going to be the objectives. So these are the objectives of the computer organization. So next we'll be going to have the syllabus. So when it comes to the first unit, like you will be going to have the basic computer organization. So as you have seen in the first CO, course outcome, input output organization and memory organization, right? So the basic computer organization. In this basic computer organization, you will be going to deal with the functions of the CPU. So what are the different functions of the CPU? Functions of input output units. Fine. And after the functionalities of the CPU and input output units, you will be going to switch to the memory and instructions. So in this memory, like you will be going to have the instruction formats. Instruction format in the sense, in order to write a program, you will be going to have different instruction sets for 8086 microprocessor. So not for 8086, like you will be going to have different instruction sets. So by making use of those instruction sets, you will be going to have the instruction formats. So 1 address instruction, 2 address, 0 address, 3 address. So all these are the different types of instruction formats. And the next important thing is addressing modes, and this is a very important question when it comes to your final exams. Addressing modes with numerical examples. So there are 12 different addressing modes. So all you will be coming to know in detail when you are going to start the unit. Fine. And next one is program control, status bit conditions, conditional branch instruction, program interrupts, and the types of interrupts. So when it comes to this first unit, this instruction format is one of the very important question, and addressing modes are one of the important question. When it comes to short answers, status bit condition and the program interrupts. These are the important questions you will be going to get in your previous, when you have checked your previous question papers. Like these are the frequently asked questions, like the repeatedly asked questions. So these are the instruction formats, addressing modes, and program interrupts. In shorts, you will be going to coming across status bit conditions or conditional branch instructions. It is a very easy subject, like, and you can say this is a scoring subject. When you concentrate, like much of the diagrams will be there. For each and every question you can expect a diagram in the computer organization. So if you are going to practice the diagrams, by seeing the diagrams only you can you can write the theory. So that is how you have to learn the computer organization subject. So this is regarding the first unit. So when it comes to the second unit, like you will be going to have the input output organization. So in this input output organization, like you will be going to have the IO interface, IO buses and interface modules. So you will be going to discuss regarding the interfaces. So input output bus, interface modules, like you will be going to have the memory, isolated memory, memory mapped IO. So these are the things you will be going to learn in the input output organization. From here, asynchronous data transfer. So this is the important question. So like in the previous question paper also it has been given how we are going to transfer the data. So synchronously we can transfer the data and asynchronously we can transfer the data. So asynchronous data transfer in the sense like in our computer, a clock pulse will be there, a timer will be there. So if every system is working upon with the timing signal, then we call it as a synchronous. Individually they have their own clocks, in the sense we can say it as an asynchronous data transfer. So in asynchronous data transfer, what are the methods? That is a strobe control and the handshaking. So these are the two methods when we are going to transfer the data in asynchronous mode. And the next one is asynchronous serial transfer. In this asynchronous serial transfer, in serially we are going to transfer the bits. So in serial in the sense a bit in the sense 8 digits will be going to send. Serially we will be going to send. We don't know what is the starting bit and what is the receiving ending bit for the receiver. So in order to make a differentiation, we'll be going to add the start bit and we'll be going to add the end bit for the data what we want to transfer. So that all we'll be going to discuss in clear when we are going to discuss this chapter. Modes of transfer, you will be going to have programmed IO, interrupt driven IO and DMA. So these are the three different modes of transfer. This is also very important question, modes of transfer. So the first one is the programmed IO, and the second one is interrupt driven IO, and the third one is DMA, which is very important. And next one is DMA controller and DMA transfer. These are the things you will be going to have in the modes of transfer. When it comes to DMA is the direct memory access. So when we are going to use this DMA, as the name itself indicates, directly we are accessing the memory. Why? Because when we are going to involve the CPU, it is going to take much of the time, or it is going to waste some amount of time. So instead of wasting that time, what we are going to do is we are completely keeping aside the central processing CPU. We are not at all using. Directly, if you want to transfer the data or if you want to fetch the data, directly we are going to fetch in the memory, and directly we are going to retrieve the data from the memory by making use of a DMA. DMA is direct memory transfer. Without the intervention of CPU, we can directly communicate with the memory. So that is the DMA, which is very important concept. So you will be going to have the DMA, that pin diagram will be there, and DMA controller diagram will be there, and how the DMA is going to work, and what are the signals that DMA is going to have. Everything we will be going to see in the DMA control and the DMA transfer. And the last one is input out IOP, CPU to IOP communication. So input output processor to CPU and CPU to IO, how you are going to communicate. And finally we are going to study regarding the Intel 8089 microprocessor, IOP. So these are the different things which are very important. Those are going to be studied in the second unit. And when it comes to the third unit, you will be going to study regarding the memory organization. As I have said you before, we will be going to have different types of memories. The first one is RAM, and the second one is ROM. You will be going to have the cache memory, and you will be going to have virtual memory, and you will be going to have associative memory. So all these are different types of memories. So why we are going to make use of these many memories? Like one memory is not enough. So and even though this RAM is not enough, so why we are going for this ROM, cache, virtual, associative? Why? Because in order to have better output, like we'll be going to make use of these different types of memories. Why we are going for these many memories, I'll be going to discuss when we are going to discuss this third unit in detail. So this memory hierarchy, in the sense this only, like you will be going to have the at the bottom you will be going to have the secondary memory, and next one you will be going to have the main memory. Here you will be going to have the cache memory, and at the top you will be going to have the CPU, and in the CPU a portion is going to be allocated for registers. So this we call it as an hierarchy, memory hierarchy. So why these many memories, we'll be going to study in detail. So you'll be going to study regarding this main memory and RAM, like a ROM, memory address map, memory connection to CPU, how we are going to connect the memory to CPU, associate memory. So let me tell you in brief, associative memory, cache memory, in the sense like cache memory is incorporated in between the main memory and the CPU. So in order to speed up, in order to match the speed, so main memory is very slow but CPU is very high. In order to match the speed, we are going to have so why we are going for different types of memories, everything we'll be going to study in detail. So cache memory is in order to match the speed with this main memory and the CPU, we will be going to incorporate the cache memory in the middle. When it comes to the associative memory, so associative memory, in the sense like if you want to fetch anything in the memory, this is the memory. So if you want to fetch anything in the memory, so we'll be going to do with the address normally. But when it comes to the associative memory, in the sense you will be going to search in the memory with the data. So with the data we will be going to search instead of address. So that is the associative memory. What is the data cache, instruction cache, what is miss and hit ratio, what is the access time, what is the associative, set associative mapping, everything we will be going to study over here. And also we will be going to have the introduction to virtual memory. So virtual memory is actually a secondary memory, we can say. Virtual, as the name itself indicates, it's not there, but we think that there is a huge amount of memory at our side. So how we are going to create that illusion, so everything we will be going to see in the introduction to virtual memory. When it comes to the fourth unit, it is totally dedicated to 8086 microprocessor. It is completely of 8086 microprocessor. So here we will be going to start the special functions and general purpose registers. We will be going to discuss the segment registers, what is the concept of pipelining, and what is the flag registers you are having, and addressing modes of 8086. So each and every topic is very important. So segment registers, we will be going to have different segment registers. We will be going to have different general purpose registers. General purpose registers, in the sense like 8086 is a 16-bit register. It is a 16-bit register. So in this 16-bit register, like you will be going to have 8 divided into 2. So here we will be going to have AX and BX. Totally we will be going to call AL and AH. Today we call it as an AX. So this left hand side, this is higher order and this is lower order. So this 8 and 8 total comes 16. So AX is nothing but AL plus AH, we call it as an AX. So these comes under the general purpose registers. AX, BX, CX and DX are the general purpose registers. You will be going to have the accumulator. This AX register we call it as an accumulator also. So everything we'll be going to discuss in detail. In segment registers, like you will be going to have the stack segment, code segment, data segment, and extra segment. These are the different segment registers. These are the 4 segment registers. Why we are going with this 4 segment registers and what are the use of these segment registers, you will be going to know. And concept of pipelining. So pipelining in the sense, like in 8086 architecture, this architecture is divided into 2. So the first one is like you will be going in this first part, this is the second part. This we call it as a bus interface unit, and this is called as the execution unit. Totally we say it as an 8086 architecture. So in this bus interface unit, you will be going to come across the pipelining concept. So what do you mean by pipelining? Everything we will be going to see clear. Fine. So 8086 architecture is divided into 2 parts. The first part is a bus interface unit and the second part is the execution unit. In this bus interface unit, a portion we will be going to have the pipelining. So that is the pipelining. Flag registers. So there are 9 flags you will be going to have. So different flags indicates a different indication. Sign flag, zero flag, parity flag, carry flag, all comes under 9 flags will be there. So that also will be going to decide. Addressing modes, I have said you 12 different addressing, direct, indirect, register, direct, indexed, all comes together. 12 addressing modes are there. So all the things we will be going to have in this 8086 microprocessor. And the last unit is of instruction format. So in this last unit is completely of programming. So in this you will be going to have the branch and call instructions, sorting, evaluation of arithmetic expressions. Everything we will be going to make use of mnemonics. We will be going to make use of the instruction set of 8086 microprocessor, and we will be going to write and we will be going to learn the coding for this 8086 microprocessor. So completely programming part is of 5th unit. So these are the different 5 units which is going to cover each course outcome what we have studied in the course outcomes on the first slide. Like all the outcomes, like at the end of your syllabus you will be going to have the knowledge of all these things regarding the 8086 microprocessor, regarding the interfacing, regarding the IO organization, regarding the memory organization, and regarding the instruction set of 8086, addressing modes of 8086. Everything you will be going to coming up, everything will be going to be in your hand, and you have completed this course successfully. Fine. And last thing is the textbooks. Like for this computer organization, the preferred textbook is Morris Mano. So the first 1, 2, 3 units will be going to have in this Morris Mano, and regarding this 4th and 5th unit, that is 8086 microprocessor. So 4th and 5th units are 8086 microprocessor. So for that microprocessor you will be going to have this HAL and or AK Ray. Fine. So HAL textbook is very much preferred when it comes to the 8086 microprocessor. But when it comes to the normal 1, 2, 3 units, the very much suggested book is Morris Mano, and thus William Stallings is going for the reference book. So William Stallings is also one of the best edition for the computer organization COA. We call it as a COA, which is going to be very much preferred. In easy terminology you can find it. So these are the textbooks and references for your computer organization and the architecture. Fine. So this is the detailed brief introduction regarding your subject. So don't get bored, as it is a theory subject. You can understand it very much well. Why? Because you are having the practical session. So in the practicals also you will be going to make use of this MASM software. MASM software, Microsoft Macro Assembler. That is the software in which you are going to do your programs, lab programs. Right? That's all for today, and from the next class we'll be going to start with the first unit, the introduction of the first unit, and some of the concepts in the first unit we'll be going to do in your next class hopefully. And thank you all students, have a great day.